Hello guys, welcome and welcome back to my channel. For you new guys, please I request that you subscribe to my channel, and to the existing subscribers, I cannot thank you enough, man. I know I've not paid anything to anyone for them to subscribe. I so much appreciate your good work. Continue supporting the channel as we help each other in our advancing of SolidWorks. For those that are new, we have been dealing with our layout. You can check the videos, the previous videos, and we are at the cooking, the hot kitchen, and we are designing this cooking range. As you can see, we have done a couple of videos. It's a series of videos, and we have done a couple. We are continuing with the same range, and for those that have been following, you notice a few changes here and there, like these openings were not there. These are for the gas taps and for the opening for igniting the burners and all that. This is a collection, a drip tray collecting the oil. Yeah, I will revert back to it, to whatever you're not seeing, and we shall talk about it. Today I want us to talk about the double well deep fat fryer, and the opening for the well for the fryer is this one, and we are going to be designing the fryer. If I could pull the evaluate and go to measure, we see what is the size. I believe it should be 600 by 540. Measure normal distance is 600 by 540, I believe. It is always good to be sure of what you're doing. Yes, 540. So having confirmed that, let us go ahead and start with the fryer, and with that we are going to open new file. Then we go to part, new part, click OK. My custom units is millimeters, grams and seconds. I've been using millimeters, so we keep that. Then go to the top plane and start our new sketch. We choose center rectangle, snap it to the origin, smart dimension it to, instead of doing 600, let us do 598 for the purposes of ensuring that we have allowance. This is 540, so we do 538. Okay, now since the fryer is a drop-in and it's not going to be welded permanently onto the cooking range, we have to make some provision on how it will be supported, and that we are going to make an edge flange starting from here to here. We could smart dimension this. This is 30 millimeter. Also to the front, 30 millimeter, and the other side also keep 30 millimeter. From the back we leave it as it is. Now since it is a double well fryer, let us do the partition. The sketch that you are seeing here is for the purposes of creating relationships when we start with the base flange. I did do a center line there from the origin, then I created another line and smart dimension this to 15 millimeter. And then I will choose the line and mirror it about a center line that I delete. I want to mirror it about that center line. Choose click OK and exit the sketch. Like I have said, that sketch is for the purposes of creating relationships. Now go back to the top plane. If you want, you can create reference plane. If you don't want, you can leave it as it is. Once you choose your top plane, start a new sketch. Choose corner rectangle, snap it from that corner to this corner. Then go to sheet metal and choose base flange. And material parameters, thickness is 1.5, sorry. The other factors remain the same. Right click to exit the base flange. Then go to edge flange, choose this edge here and this here, and create an edge flange and condition blind sizes. The depth of the wells will be 200 millimeter. Right click, then again edge flange, choose this edge, that direction, click OK. Then edit the sketch so that you may make it collinear with our initial sketch, so that that bend there becomes 30 millimeter. Okay, that being done, we go back and do edge flange. Here we are creating the wells, and the size of this is 200. If you want, you can select, you know, the edge flange up to vertex, then you choose the appropriate vertex, which I believe is this one. But since we have given it a dimension, a blind and a dimension, that would be okay. The other one, you don't have to worry about dimension in it. Just do a flange, then edit the sketch and make this line, that edge should be collinear with this. Make them collinear, exit the sketch. Again, edge flange. We have so many edge flanges we are making here. This you can give it a dimension of 200. You want your, the wells to be uniform. Then do an edge flange on this side. Don't worry about dimension again. The first stage is helping us with, the correct relationships, so that we may keep the dimensions of the fryer. Exit the flange. Now I think I should have edited it and created the 45 bend that's supposed to be here. I don't know whether that is 45. We can always confirm whether this is 45. It is not 45. We need, what did we see? 43 point something. 43.53. Let me note that someplace. But we need it to be 45. Yes. Let us delete this relationship so that we may give it a 45 degree. Otherwise, we will have problems when we are doing the front part. Yes, that looks better. Okay, so having done that, choose this line and make it construction, then exit the flange, exit the sketch, and your flange is good. Now choose edge flange again on this side, and this also make it 30 millimeter. That bend that will be there. and finally edge flange here of 15 millimeter. Most of the time we have been finishing our flanges with that 15 millimeter. So edit this sketch. Do you have to edit? Now create a new sketch here. We want to notch this part here. You can choose convert entities and choose this edge, not that face, but that. We need the edge, we need only that edge. Right click, then draw a line, select a line from, you can do it from there to there, then choose extend entities, and entity to extend is that. Yes, then right click, choose trim entities, trim this and trim this. Once that is done, exit the trim, go to feature and extrude and cut through all or link to thickness or something. Our notch is made of 45°. Now since we are done with this sketch, you can go ahead and hide it, then choose the right plane, go to mirror, and what you want to mirror is this edge flange, this edge flange, this edge flange, and don't forget also to choose the cut. Click OK, and all that will be transferred to the other side. Now as you can see, we didn't have to do edge flanges here, we only mirrored what we had here, which is pretty much okay. And I can notice that we have something is not happening here at the middle. Let me see. Now this is supposed to be 30 millimeter. I know what happened here, but it is supposed to be 30. I noticed it was a little bit smaller than the other edge, the other bends. Okay, now it looks uniform, right? Okay, now we go to this and start a new sketch. Choose a center line. Do we need a center line? We can do a center. No, we don't need a center line. Actually, we need just to do a circle. Circle is opening for the drainage, and make this and the midpoint of this edge flange, make them vertical. Okay, that being made, yes, we need a center line someplace. We need a center line from the origin, which will assist us in mirroring the circle. Smart dimension. This we can do a whole of dia 20. Ideally it should be dia 25, but I'm going to do dia 20 because I have 3/4 ball valve, and I intend to use that. Otherwise, much later we are going to make a ball valve of a 1-inch ball valve. That being done, choose mirror, select the circle, mirror about the center line, right click, then go to feature, extruded cut, and linked thickness. The drainages are made. If you want, though this is a small thing, when you're doing your fabrication, before you do all these bends, you can create a kink here and kink here to ensure that all the oil will be drained from the wells. Okay, but this is a small well, I don't think that will be an issue. So we save this as part number 1. I have a folder here which I called a fryer, so I save this as part number 1 and name it fryer body. Then I will go and open a new file and create the front panel. So I'll choose the front plane, start a new sketch, center rectangle, snap it from the origin, then I smart dimension it. This we gave it 598 and the height is 200. That's okay. Sheet metal, base flange parameters are the same. Click OK. Let us create an edge flange there, 30 millimeter. End condition blind, 30 millimeter. Click OK. Now we edit this edge flange. We edit the sketch. Let me not flip it to normal, so that I may be seeing what I'm doing. And with that, I create a line from this edge. I think I need to flip it to normal. Create a line from here to that direction and to this edge. Click OK. Then I create another line on this other side. Click OK. Now I do my smart dimension and I will maintain the size of the edge flange. It is 28.5 because of the bend allowance. Then this I make 45-degree, and the other side also I do 45-degree. Then choose this line and make it construction. Choose this other line here and make it construction also. Exit the sketch and your 45-degree will be created. That is pretty much okay. Now go ahead and make the other edge flanges. This is going the downwards direction, and condition blind, size is 30 millimeter. Click OK. Then again edge flange on this side, the 15 mil edge flange, size 15 millimeter. Click OK. Now choose this and start a new sketch. Convert entities and convert that edge. Right click, then do a line. You can do a line touching this like that, like that. We want to trim, to notch this bend into a 45-degree. Extend the line, right click, choose trim, just like we did with the other one. Same procedure applies. Exit the trim and go to feature, extrude and cut. Make your cut, and your 45-degree looks pretty good. There is something which is protruding there. I'm sure you can address that. Now if I could go to the right plane and select mirror, and what I want to mirror is that extrude, is that cut. That is what I want to mirror. Click OK, and I'm sure it has been effected on the other side. Now save this as part number 2. Call it Fryer front panel. With that part saved, we can go ahead and start our assembly. New assembly, click OK. Now the first part we are going to insert is the body. Okay, We can make it float so that we may do some relationships. We create some mates. Choose the front plane and mate it with the front plane of the working space. That is the front plane of the fryer and the front plane of the workspace. Click OK. Yes, see, I did change the settings. Now I can do as many mates as I want, unlike what was not happening yesterday. Right plane to right plane. There we go. Now it is in my power to choose when to exit the mate. Fix it. Okay, right click, choose right click, then choose fix. Insert component. I want to insert the front panel. In the front panel, I want to do my mating, and this mates with this face here, because there is where you're going to do your welding, and the top of course flashes with the other bends. Now I choose the right plane and the right plane of the front panel. The right plane of the front panel. That's good. Now the reason why when I'm doing these things I don't do each part alone is because of this gap. See how big that gap is. I prefer doing the component all together. Then when I'm exporting parts, when I'm exporting the parts to be cut using the CNC, the flat pattern, that is where I will separate them on AutoCAD. But hey, I know you can fix this, and should you know how to fix this, because if you were to do your welding with such a big gap, yeah, you are going to have a terrible welding and the finish won't be that nice and smooth. Okay, and I'm wondering why this is not coming to, why there is a small gap. Can we open this and edit the sketch of the base flange and make it 600? We see what happens. 600. We want to see whether it will fix that and the gaps and all that. The gap is still there. Actually, that panel has become slightly bigger. But when you're doing your fabrication, you know, you can't stay away from the grinder. The small, is it 6-inch or 4-inch grinder? What is the size of that grinder? I forgot. 598. Let us keep it as 598 as the others. Okay. Now with the assembly, I'm going to save this, save all, and save it as deep fat fryer. You can call it whatever name you feel appropriate. Now let us go ahead and do the back panel. The back panel, we choose new part, click OK, go to front plane. Front plane, start your new sketch, send a rectangle, snap it from the origin. Smart dimension, this should be 598 and this is 200. Sheet metal, base flange, parameters the same. Exit the base flange, choose this face and start a base flange or a tab if you want. Now choose a corner rectangle. Don't snap it anywhere because we will create relationships. Choose this point and the origin and make them vertical. Choose this line and this edge here and make them collinear. Then smart dimensioning this and this to 30 mil. Not 300 but 30. I hope that will be the same on this other side. Now exit the sketch and make sure you merge the results. That's good. There you have your tab. Something we didn't do there, we did it very fast. We should have dimensioned the height of the tab, which should be around 100 or 80 mil. 75, 100, that would be good. Exit the sketch. Now choose edge flange from the top, and the edge flange is at a degree of 30 millimeter, a degree of 30. I find 60 to be too sloppy, so 30 feels nice to me. And the end condition blind 75. It's a good size. Right click, exit the flange. Another edge flange going in that direction. Make sure it is perpendicular to this face. Perpendicular, not parallel, but perpendicular to that face, and make end condition blind. Make it 50 millimeters. That's 2 inch. That's good. Then end condition again, not condition, but choose edge flange there, and this should be 15 or 20. I think 20. What do we intend to do with that? Yes, there will be some holes for some screws for the panel, hiding the electrical connections. Okay, finally do your edge flange here of 15 mil. Click OK. Now I want to do some openings here for the, so I start new sketch for the eating element. I choose center line, then I will choose a circle here and do a circle here. Let me first smart dimension from here to here. Didn't choose dimension. I think this should be 300 or 299, so I'll do another center line somewhere here, then smart dimension the center line from here to here, do 299 over 2, so that the center line will be at the middle of that well. Now the copper pipe, the eating element should be at least 75 millimeter, not at least. Well, your electrician will sort you out as far as that is concerned. Mine, I'm going to keep it 75, so I'll choose 75 divided by 2, and the diameter of the copper, the eating element, why am I calling it copper? The eating element, I will keep it as 8 mm. I'm not quite conversant with the eating elements and their sizes and all that. I will take a look at it when we are doing our next installation or something like that. Choose the circle, mirror entity, and mirror it about this line. Then choose both circles again, mirror, choose this circle and this circle, and mirror mirror them about the center line from the origin. Now also here I will do a circle. I'm not sure whether this circle will work. No, let me finish with whatever I have. I don't want to end up getting confused and repeating or doing some other things. I extruded cut, linked thickness, click OK. Now those holes are for the eating element. Right, now choose this edge flange and start another sketch. Here is where your basket holders will be, and I choose those two holes, make them equal, then choose the centers and the center of the edge flange and make them horizontal. Then I smart dimension. No, I think I should do a center line here. And that center line is is the same, not about, it's the same as the other center line that we had created previously, that is 299/2. Then between this and this we make it, the basket holder can be of dia 70, not dia 75, but the distance should be 75/2. So is this other hole here, and the holder I'm going to make of a rod of 8mm. Diameter of the holes will be 8mm, the rod, right? You can do 10 or whatever you have. Okay, center line again, and select this circle and this circle and mirror them about this center line. Click OK. Go to extruded cut, cut those holes, and you are good. Anything else to be cut there? I don't think so. Now let me save this as part number 3, which is fryer back panel. Notice that I'm not just saving as back panel or something like that, because in our main assembly of the cooking range you might find that you have other parts that you had saved as back panel or front panel or things like that. And if you have 2 or more components, different components bearing the same name, when you are doing your assembly you will have all sorts of issues. So it is good for you to make sure that each part has a unique name. I'm doing assembly, that to that. Then this part here will be not flashing if you want to that face. Then I will choose my front plane, right plane, and the right plane of right plane of the back panel. Mate it like that. Now the fry is taking shape, which is good, which is very good. Yeah, sure. Exit the mate. And now real quick, you will do your welding here, welding here, welding here, and welding here. Nice weld here and nice weld here also. The other welds, here you will do welding, and here, and on this other edge. Now here you can do a very nice weld and make sure that the weld doesn't penetrate inside. Also this corner and this corner. If you want, you can notch this. You can notch, see the lines, see the two lines. You can notch the back panel and weld this independently and independently from the outside, making sure that no welding will penetrate inside the fryer, because you want to make sure that your fryer is neat. Remember, this is something that will be cooking food directly. You know, it's not like you're going to have a pan inserted in here. Even though there are the baskets which will be holding the whatever you are deep frying, still the frying medium, which is cooking oil, will be in direct contact with the fryer. Okay, so you need these joints to be very clean and very neat. That one you must be sure. So the welder that you're using, make sure that it is top class. I save this. Now I want to create that cover that covers this area and the other side, and for that I'm going to use a lazy man's way of doing it. So I will open this part, then save this part as a copy and open that copy. This I will call fryer back cover left. That should be what, right cover. Okay, now you don't do this, okay? Please don't do this. Don't follow, you know, I want you just to make sure that you can see what I'm doing. You can create this part on your own. Don't follow the lazy man's way of doing it. Though it is accurate, but do not follow the lazy man's way. I'm converting entities and I want to convert all these edges because that cover should fit in here. You can also take the dimensions and instead of following the lazy man's way, you do it right. Okay, that and this, then click OK. With that done, let me choose line and do my line from here up to somewhere, then to this point, click OK, then choose this line and make it vertical. Now as you can see, there is a 30mm bend here which also needs to be covered, so that we are going to edit it in a short while. Exit the sketch, choose one edge flange here and hide it. It hides everything else. That's why I was calling this a lazy man's way of doing things. Now choose the sketch and edit it. Do a line from here to here to here, then here. Okay, smart dimension this, make it 30mm. The bend there I believe is 30mm. The edge flange that we had created earlier. Then select this line and make it construction. Go to sheet metal, choose base flange, and there you go. You have that piece that will be covering the back, the opening. Okay, with that being done, create an edge flange here of 15mm. If you want 15mm, 15 mil, click OK. Now, why was I calling it a lazy man? See what happens if you decide to get flat pattern from it. it will give you so many errors. See, you can't export this, you can't save this as DXF. I don't think that you can. Well, we can try and save it as a DXF file and see what we will get out of it. Probably I'm just saying that it's a lazy. I don't think that it will give us something nice. Bent lines, flat pattern. See, it is giving us, I don't know. Let's see what we get. See, this is very much inaccurate. You know, you export this and start cutting this from your CNC machine, you will have something which is very terrible. So don't do that. I know you know the right way of doing it, so please follow the right way, which is to create a sketch on its own, give it the correct dimensions and all that, get your base flange, edge flanges, and you're going to get your flat pattern. Okay, having said that, let me first close what I don't need. I don't need that. I don't need these. I don't need this either, but I sure need the cover. For the cover, let me continue with the assembly and insert the cover. The cover, then we do some mating. This flashes with this. This comes slightly there. Then this face will be touching on this face. Click OK. That mat is complete. Now, as you can see, the fryer is well covered, and here you will do your welding. Oh, you don't necessarily have to do full welding here. You can do nice long stitch welds there. Now, the purpose of all these is where you're going to put your electrical components, your conductors and cables and what have you. And also the heating element will be protruding. The connection will be from this side, yeah, and you want it protected, don't want it exposed. Now we can't mirror this because of this degree. If we mirror it, the degree will go to the other side, and the bend, the edge flanges will be on the other side. So what do? We open the part and save it as a copy and open, and call it left cover. Left cover, and this will be part number 3A. Save. Then everything remains the same. What we are going to do is select this bend and edit the bend, just change direction. Same applies to the other edge flange. This edge flange, select edit, change direction also, and your left cover is good. Save and go back to the assembly, insert component and insert the left cover. Left cover, that's nice. Now do the mating, select this face and this, right click this face and this face, right click this face and this face, and right click, then exit the mat. That is very much good and in order. Now let us do the cover. The removable part, which will be bolted on this edge and on this other side, and we might be having a problem. Our covers are slightly bigger. That is why you are seeing the edge flanges, they are overlapping. You just need to adjust the dimensions slightly. Now, what is the dimension? What is the measurement from here to under here? That is 199, around 200. I'll do 200. Let me note someplace. The height is 200, and from here to here, that should be 617, 618. We round it off, and the depth should be from here to here. It's 87, 88 depth. Okay, let us go ahead and create that part. So I'll go to File, Create New Part. Okay, front plane, new sketch. People from the background, you can hear from the background a lot of noise. Kids have taken a break from school. That's why you can hear all the shouting and the hullabaloo they are playing. This we saw is 618, so we give it 2mm allowance. We do 616, and the height here is 200, so we can do 198 and go to sheet metal, base flange. This panel can be, but since the length is a little bit big, you can maintain 1.5mm, but should you have an offcut of 1.2, that would be good. This we saw was 88, we can do 86, and condition blind 86. I don't think that there is anything else that is required to be done from there. The only thing that you can do, and that you will do as per the instructions of your electrician, is to make provision for the cable, for the electrical cable, the loading cable, the one that you will be connecting to the socket. So I'm saving this as part number 3, back electrical cover, part number 3B. We call this electrical cover. These are just names. B. Save. And I will go to my fryer and insert component. Where is my fryer? Actually, I should close this and this. Be left with the fryer. Insert component. Back electrical cover. That's nice. Now mating it, this face here will be flashing to that face, and this will come absolutely under these other faces. Yeah, and this cover you can do it differently from how I'm doing it. Then go for the right plane and the right plane of that back cover, right plane, and mate them as shown. Exit the sketch. Now, why is it a little bit shorter? We open it and edit the base flange. I think no, we are supposed to edit the sketch. 616. It shouldn't be 616, because if the other was 598, will it allow us to go back here and do some measuring? Okay, don't worry, I don't need it. Let me can't access it. This dimension was supposed to be 598 plus 60 minus 2. You're wondering what kind of guy is this who doesn't want to do some little calculation, very simple calculation like that. But don't believe in why should I struggle, you know, getting my head tired while I can use the tools that have been provided by SolidWorks. Now the size is good. So what I was saying is, you punch a hole here, put insert, another one here, insert, another one here, insert, and another one here, insert, and do screws. Okay, screws, because that panel will always be removable in case you want to do your, you know, your, what do we call it, maintenance and all that. You will need to have that panel removable. You can't weld it permanently. Now, with all that done, let me close this. With all that done, I want to create the outlet for the drainage. I start new part, click OK, and I will choose the right plane, start a new sketch, then do a line here from the origin, make it vertical, then horizontal. Now this is an elbow. Let's multi-dimension this to, we can do this 30. What I'm trying to say is that this elbow, you will be required to weld a socket at the end. The elbow will be welded under there to the well, then a socket at this other end. I don't want to do a socket here, so what I will do one elbow, then create threads, internal threads, which will serve as a socket. But I hope you have gotten the concept there. Do a socket there and weld it to the elbow. This, I'm going to make it 100 millimeter because of the socket. And again, I don't want to do a very long nipple. There will be a nipple coming someplace. Now this, I will fillet this, and since the hole we created was dia 22, which I believe we don't have that. I don't know what is the size of an elbow, 3/4 elbow, as far as the thickness is concerned. I will also check on that. So I will radius that to a half the diameter of the elbow, then exit the sketch because I want to do some sweeping. Go to the top plane and start a new sketch. From the origin, I create a circle, and the diameter is 22. You don't worry about this part. These are fittings that you buy from the shop, from your supplier, and you know the diameters are fixed. So if you find my dimensions not agreeing with yours, use the appropriate dimensions, okay? Because when I'm doing the fabrication, the drawing for fabrication for these, I make sure I incorporate all the fittings that I'm going to be using and ensure that I keep the dimensions. I'm sweeping these, and this is the sketch profile that I will be using, and this is the circular path. Right click. Now it has to be hollow, so shell it. Thickness is 1.5. Select that face and this face, right click, and you have your shell. Now go to all wizard, select thread, and your thread are starting from here, and you can give it blind of say 20 millimeter. And do you want to offset? and change direction so that you may have a nice start to the threads. You can offset 5mm. This we gave it 20 so that we may have 15. The thread, I don't know, nipples have threads of what, M10 by 1. Thread size. You don't worry about these small items. We will do 1.5. We are going to have issues because the thickness there is 1.5, so let us do 1mm. M10 by 1 or 1.25, whichever makes you happy. Inbuilt errors. What are we doing? Metric die or metric tap? They should be metric die. Unable to cut surface. Use extrude. No, I don't want to use extrude there. I don't want to do that. Okay. Now before I do the threads, I will do something here. Instead of doing a socket there, I will do, you guys assume here is the arrangement. Let me start from there. You have your elbow, and your elbow will be welded to this. Okay, after the elbow you will have a nipple. No, after the elbow you have a socket which will be welded to the nipple, to the elbow, then a nipple, then a butterfly, a ball valve, then a nipple, then another elbow there with a socket. Now you can avoid all that by doing what? By getting a tube, a pipe, a schedule pipe, do threads threads on one side, weld, and the other side cut it and weld it directly to the elbow, so you will avoid so many fittings there. So that schedule pipe will be your nipple, and the threads are the ones that you're going to tie your ball valve. So let us do exactly that. So this, I'm going to elongate the sketch, edit the sketch, and make this 150, so that I may create external threads which will act as the nipple. So I'll go to the all wizard and select threads, and instead of having them as internal threads, take them outside. And don't think that I'm doing this because I wasn't able to make internal threads. I really can make internal threads. I'm sure my dimension, my whatever kind of threads that I was choosing here wasn't in agreement with my tube. If I could change the threads, you could see them being in agreement. Okay, is that clear? This we want to do 20. Then we have set this thread by 5mm. We change direction. Yes, let us change direction like that. And then here we will use metric. Is it metric die or metric tap? Metric die, and that will create our threads. Now, if you can see why we were offsetting the threads from outer, so that you may have a good start for the threads. Now go to the end, select this face, start a new sketch there, then choose convert entities, choose the face, and convert those edges, all those edges. Then go to feature, extruded cut, and cut through all. Okay, through all, and you will have a nice finish to the threads. And that part is done. We save it and call it as part number 4, which is fryer drainage. drainage elbow, drainage elbow 1, because we are going to have another on the other side. What is the length? We did 150. That will be determined by the distance from here to this panel, because once you do your ball valve, you don't want the ball valve touching the edge of there should be some clearance for you to be able to open and close the ball valve. Okay, so we go back to our assembly and insert component, and the component we are inserting is drainage elbow. Okay, then we do mating, and the first mate we are going to do is concentric relationship, and choose this and choose the hole and make them concentric. Yes, then choose this top part and the weld face, choose okay. You're going to do your welding there. Now let me exit this first and choose the body part, or I can choose the back panel and open it, then create reference geometry, which is plane, right plane, reference plane, choose plane, offset it, flip offset, and this was 299 divided by 2. 299 divided by 2 comes to what? 299 divided by 2, that is 149.5. 149.5. Yes, I believe that should be at the center of the hole. Now we can hide the plane, then go back to our assembly and do met, expand this, go for the fryer drainage, choose the right plane, then go to the back panel, choose plane 1, and you met them. So when you are doing any other met, this tube won't be oscillating, there will be zero movement there. Now let me insert something here that you have not seen me do design. We will design it some other time, and that should be the elbow, not the elbow but the ball valve. I have a 3/4 ball valve that I did a couple of days ago, if not months. There is my elbow, why am I calling it elbow? Met this, and the first met I'm going to do is to ensure that my threads are coming all the way to somewhere there, that one and this one. Okay, what kind of met was that? Then I need to do a concentric. That I did. I don't know whether I did it right. No. Actually, I should just cancel the met, exit the met. So let me first do a concentric met. Concentric relationship between this, can do this, and this tube. They are concentric. And let me pull it like this, and I can choose. Can I choose distance? I can choose distance. Yes, I will choose distance. I'm wondering distance 15 from here from there to here. No, 15. Can we 15 is small. 25 is not good. 25 is big. 15, the threads are inside. The threads have gone inside very much. 5mm should be 2mm. Yes, something like that. Okay, then I will go to plane number 1, plane numero uno of the back panel. That plane, then I will expand the ball valve. I don't know which plane I will be using here. The right plane, yes. See now the ball valve, if you are to rotate it, it can't rotate. Now, before we continue much with so many other things, let us bring this sub-assembly to the main assembly and see whether our distance, this length is good. Okay, so I will go to the cooking range and insert component, and component to insert there is the fryer, all of the fryer. Then I will do my mating. The first met is, I will do a advanced met and choose width that is between these and these. Should be at the middle of, not at the middle, should be here between that and this. Okay, now that being done, let me ensure that I have only 1mm distance between this and this. Just an allowance of about 1mm, 1 or 2mm. Now, finally, this will be our support to the fryer. It will be resting on the top of the cooking range. Did we choose right? No, we are not supposed to choose width, but standard mate and make that coincident relationship. That is good. Now, don't worry about the holes. The holes, we are going to redo them. If you can see, our nipple is shorter. It's short. The handle of the valve is almost touching the front panel of the range. So we will go back and open the elbow and nipple. Then we go to the sketch, edit it, and make this 200. That is why I was telling you, this distance will be determined by this. the distance between there and the fryer. Now you see your elbow is your butterfly valve, your ball valve 200 seems to be a bit long, but it is not bad. It is not bad. If I could choose which from this ankle, you know, it is not bad. It won't be interfering with any operations. Okay, now that is good. Now we need to, I said don't worry about these holes, we will redo them. We need to do an elbow. Okay, one thing I should mention here is that when we are importing the fryers, the deep fat fryer, sometimes we normally import them and come do some little modifications, like, you know, removing the legs, because most of the time they bring us freestanding fryers, so we remove the stand or the legs and use them as drop-ins into our cooking range. Most of the time those fryers come with no elbow here. Imagine a situation whereby the operator, the chef who is using the kitchen, has finished and they want to drain the oil. The oil is super hot, and if they open the valve and they are standing somewhere here, it is most likely the oil will come to his body, and that can be really dangerous. So to avoid that, please do another elbow here and direct the oil towards the ground. At least here you have high chances of avoiding accidents. Okay, so I will do that elbow. I will do an elbow here. I create new part, select the right plane, new sketch, and this elbow also, remember, it has to have a nipple welded on that side. I don't know whether there are elbows which have nipples. This we can do 50 and 30. Then we do fillet, and the size is 11. We didn't check whether those dimensions are in agreement with our nipple, our ball valve. We will check, then start another sketch. Go to which plane do you need, front plane, start new sketch. From the origin, do a circle, center of the circle from the origin, diameter of the circle is 22. Exit the sketch again and feature sweep, and what you're sweeping is this sketch here. No, do they make a difference? Yes, a big difference. Let me clear this. So the first sketch is this. What's not happening here? I want to select this. Why can't I select this line? And why is it that what's not happening? Yes, then this. Yes, there you have your elbow. Now shell it again. 1.5. It's the thickness. Choose this and choose this. If you don't choose both pieces, it won't be hollow, it won't be open. Then go for all wizard thread. Your threads should start from here, just like we did the other, and offset here by 5mm. Change direction, and I believe you are good. M10 by 10 metric die, you're good. Natural. If they are not matching, this is just for representation of what we are doing. You know, like I keep saying, your components, you get them ready. This is 4B. elbow 2. Save and rebuild. Then we go to the assembly of the fryer. Insert component and component to insert. There is elbow number 2, number 2. That diameter is way too small. We'll change it. Now met. First met is concentric relationship between this. Yes, and this. Yes. Then we can do a distance of 20 between this face and this face. Flip dimension. 20 is big. 15 is good. 15 looks good. Click OK. Then go to that plane that we inserted, that is plane number 1. Where is plane number 1? Plane 1. And where is this elbow? Plane 1. Let us collapse this and collapse this and go for that. Yes, it has made it very vertical. Now remember, you need to use some thread steps as you do, these fittings. Let us change this to, let me see, edit. Can I edit that? No, I don't need to edit it. What if I select this and start a new sketch? For the purposes of getting this diameter, the diameter of that wall, circle, will I ever get the center? Yes. Let me get this diameter, 24.75. Exit the sketch. Don't save nothing. And open this. Go to sweep. Sketch number 1. Edit it. And this radius should be 24.75 over 2. Exit. Then go to sketch number 2 and edit it to make this 24.75. We didn't even give allowance. Anyway, you know what we are trying to achieve. So save this. Then we go to the main assembly, the sub-assembly, and the elbow is fitting. Yeah. So ideally, that is how the fryer should look like. Now I will do this holding basket brackets. New part. Okay. Then I choose. How we select front plane? No, we select top plane first and start a new sketch from the origin line, like this, like this, like this. Select OK. Choose this line and this, make them equal. Smart dimension. This, remember our opening we did at 60, and this should be something like 50 millimeter. Then fillet the radius, and fillet radius is 4 millimeter because the road is 8 millimeter. That in this, click, right click, exit the sketch, then choose right plane, not right plane but front plane, start new sketch. From the origin, circle, do a circle of diameter 8 millimeter. That is the size of the rod that you're going to use for that holder. Exit the sketch, go to feature and sweep. Sweep this, the first sketch. No, why is it that I'm missing that sketch and this? And this should be solid. Save it as part number 5. Call it basket holder. The A should be smaller. Now insert component, close this, save all. I'm closing that and I'm closing this. I don't need them. I don't need also this. Then I open this and insert that holder. Then I choose Met, and I will make this concentric. This to the hole, this should be concentric relationship. And if you want, how much did we do the hole again? We will go back and see how much we did for that. Let me first hide this so that I may see where my rod is coming, and met it this face and this, because you are going to weld your rod from here. Now that being done, let me also choose concentric relationship between this and this. It won't work. It won't work. It won't work. Let me first make sure that I get that whole dimension of that hole. What did we hide? This part, make it visible. Make it visible. Then we can choose this and edit. We can edit it from here, and what we are editing, where is it? What are we editing? Back panel, extrude and cut 2. That we edit the sketch. We just want to know the dimension of that sketch. 37.5. That should be, is it 75? 37.5 times 2 should be 75 times 2. What am I doing? Thirty-seven 0.5 times 2, 75. Yeah, I think 75 is ideal. 60 looks small. 75. Exit the sketch, exit editing, then choose this. If you want, you can edit from there. You don't necessarily have to go and edit from the part. Make this 75. Choose OK, save the changes, go back. Now you see it is at that center. Now choose Met and make those two components concentric. That is between this and this, concentric. Yes, that's good. What else can we do? Now, before we continue, let us go to the right plane and choose mirror components, and we want to mirror this. We mirror this. No, this we don't need to mirror. If you mirror that one, let's see if they will be flipped. I'm sure they will be flipped. See, this is flipped, that one is flipped, this one is good. So let me choose this and this and delete them. I will insert them again and do the mating, the necessary mating. Now the remaining thing here is the eating element. The eating element, that is what we are doing next. Part, choose OK, and here we will go to 3D sketch. 3D sketch, and this 3D sketch, last time I tried doing a 3D sketch, I encountered all sorts of problems. This 3D sketch gave me all sorts of problems. So I will select this. I think I should hit tab. Then I hit tab. I hit tab. Then tab on the keyboard. Then tab. My tab should lock it to which tab? Tab. No, I want to lock it on that axis. Then tab. This is something that you shouldn't worry about doing, because I'm sure your electrician knows better. And finally, like that. Let us see. Yes, it is good. Now I choose this line and to make them equal. Then I choose this line and also make them equal. Then I choose this and this, make them equal. Then this and this, make them equal. This line and this. Sorry, it is this line and this, make them equal. Then I start my smart dimension. There is something I can't remember. Let me do this at 230. Then this at 400. Then this I do 300. then this I do at 20, then this I do at 15. Like I'm saying, what is this now? That should be 75. Not really. Now instead of making this 15, let me delete it and make this make this 75 from here to here. 75, that is good. I believe this is big, that is why we are having that problem. 10 is big. 15. Yeah, let me keep it like that. I exit that sketch, then I will go for the front plane and start a new sketch. Circle from the origin, diameter of that circle is 8 millimeter. There is one dimension there that I will edit once I confirm the opening of that hole for the element. I also did the 3D sketch. Let me edit. I didn't dimension this I should dimension to something like 100. And also, since I'm in edit mode, I fillet 4 millimeter, that is between this and this and this and this. Right click, exit the sketch. Now I go to feature and sweep, and what I'm sweeping is this circle and that sketch, and the element is there, the eaten element is there. Let me save this. It is not that perfect, okay, but I believe your electrician will help you with this. This is just for the representation. 18 element. Now let us, and you know there are some funny things that are normally here where you come and do the connection, termination of the cables. Now let me insert component, and component to be inserted there is the element, the eating element. We will check whether the sizes are good, and concentric relationship as we do the mating, that is between that and this. That's right. Concentric again between this and this. Is it so? Clear. Delete. No. First of all, let us leave it at that. We choose this. Shouldn't have done it like that. Met, and I will give it a distance of 10 millimeter between this and that. Should be 10 millimeter, about 10 millimeter or something like that. Now the size of the element looks a little bit small. Yeah, you can increase this to say 100 or 120 so that this might expand a little. Okay, let us do that. Select this, edit the sketch, cut 1, extruded cut 1, edit that to that, this and this 75. Let's make this 50. Yes, exit the sketch. Then once that is done, we choose this, open it, go to 3D sketch and edit. We edit this from 75 to 50 to 100, sorry, 100. Yes, 100 will do. Then we can make this 25. 25 is way too big. 20 looks okay. Looks okay to me. No. Let me, what if I choose this and this and make them equal? Any harm? No harm. Actually, it has become a little bit realistic, a little bit more realistic than it was before. Then we go here, save the changes. Then we can make this met concentric. This concentric with the hole. Why are we having problems? We have received so many errors there. I'm sure it is because of one thing. My 3D sketch seems to be having some issues. Open 3D sketch, edit. I don't know why, and this is equal to the other, this point and this point. Is there a way we can align them? That is where the problem is. That point, actually this point, that is where we have issue. You know, our 3D sketch is not that perfect. If we were to look at it from is it from there? We have a problem with our 3D sketch. But hey, just please bear with me. I'm sure these 2 points are not aligned, but at least you've gotten a complete overview of how a fryer looks like. What will be remaining here is to create a cover for the fryer, for the eating element. Okay, we will fix this at a much later date, which I don't know. Let me mirror components. I don't know whether it will work. Nah, it can't work. Delete, close. I will insert component and I will insert the eating element, then met concentric between this and this. then distance of about 10 mil from here to here, 10 mil. Then I will leave it at that. Then I will insert again, insert the elbows, browse, elbow 1. I should have inserted everything. Met, concentric relationship, concentric between this and this hole. Yes. Then between this and this, not concentric but coincident relationship. We'll go for coincident, this and yes. Let me insert, browse. I will go for the ball valve, and I will make concentric relationship, that is between this and this. I don't know whether if I make coincident, I choose this face and this. Yes, I'm not sure if I do what, I make another relationship between yes, between this face here and this face here will make. What happened? No, we don't need to do that. Let me leave it at that. Can I mirror component? If I choose the right plane and mirror, then I mirror this elbow. Yes. There's some errors here and there because of that heating element. The heating element is giving us all sorts of problems. Save. Finally, we are going to do the element covers. Element cover, we measure between this and this. That is 284. 284 by what? This and this is 538. 284 by 538. New part. Okay. Top plane, origin, center rectangle to the origin. 284, we can do 285. 284, we do 280. By 534, we can do 500. Sheet metal base flange. 1.5 is okay. Then edge flange here, the 3 sides. Actually, you need edge flange 2 sides. Delete this side, and this you can make 20. You don't want the element touching the bottom of the well. 15 millimeter. That's good. Then you want to create holes. Diameter of the hole can be 10 millimeter. 10 looks small. 20. Then from here to here you can do 30, and from here to here you do also 30. Then you go to feature and extrude a cut. Click OK. Then from there you choose linear pattern. Direction is that. Component to linear is the extrude cut all. Component is extrude and cut. You change direction. This make, is it 50? Will 50 be good? 50, then you increase the number of holes. Then direction 2 is that one. Then make this 50 also. Then increase the number of holes to something like that. You can edit accordingly to make sure that the holes are centered on the plate. Then save this and call it. Part number 7. Element cover. And with this, I believe our fryer is done. Fryer is done. There are some mates that I should add to ensure that this thing is not oscillating like this. See? I will add it a bit later. Simply insert element cover. There we go. Met. I will go to plane 1. That is the back cover. Back cover. We go to plane number 1. Then element cover. We go for the right plane. Click OK. Then I will do what? Choose this and this. That's okay. Then I will choose advanced method, go for width, that is between this face and that face, this face and this face, and your element is covered. Your element is covered. Okay, ideally that is how you go about this thing, and that cover is removable. Mirror, will this give us troubles with the mirror? The bends are good. Okay, now I choose this open, and when that is opened, let me see this. I edit 149.5. Okay, so I'll go for right plane and reference geometry plane 149.5. Yes, and hide the plane. Then go to the sub assembly. Then I will choose. All the errors are coming from the element. Then I will go for met. I will met if I choose plane 2 of the back cover, plane 2, and I choose the ball valve, go for the right plane. That should align a few items. Then I need to choose the right plane of the ball valve and the right plane of which elbow. No, we are having problems with this because I didn't insert it. I mirrored. Don't worry about the errors. Once we fix the element, the errors will disappear, the errors in the mating. So this, we go to mate, concentric relationship, concentric between this and this. Then can we go for coincident between this and this? No. Actually, we go to plane 2 or not element cover, but this ball valve, right plane, and right plane. We are having problems. I will leave it at that. Now the fly is good. The only problem we have is with the eating element. That element is giving us all these problems. So bear with me, guys. I will fix for you the elements and the errors will be gone. Let us check from the main assembly and see if our thing is good. So in our next video, we are going to fix the element and we fix these holes. Okay, no, not in our next, but in a future video. Then we'll do the baskets. Thank you so much for your time. I believe that is enough for today. We will continue, and by the time we are finishing with this cooking range, everything will be good, and we are also going to render it so that it may appear neat and smart. Thanks again for your time. Have yourselves a wonderful day.